I'm Mr. V. Ratanakumar, head of the Department of Mathematics, PPG College of Arts and Science. In this video, we are going to talk about mathematical connectives. Logic is the foundation of clear reasoning and computation. In this video, we are going to explore propositional logic using truth tables. We will move from simple statements to powerful logical system. By the end, you will see how these symbols form the backbone of mathematics, computer science, and digital circuits. Let's start with the most basic idea, a proposition. A proposition is a statement that is either true or false, never both. In logic, we represent statements using variables like P and Q. For example, that P means it is raining and Q means I have an umbrella. Each statement can only take one of two values, true represented by 1 or false represented by 0. The simple truth values are the building blocks of everything that follows. Now let's apply our first logical operator, negation. Negation is written as not P or symbolically negation P. Its job is simple. It reverses the truth value. If P is true, negation P is false. If P is false, negation B becomes true. You can think of it as a switch that flips the value. With negation understood, let's combine two propositions. The next proposition is conjunction. Conjunction is written as P and Q or P cap Q. The statement is true only when both P and Q are true. If even one of them is false, the result became false. So AND is strict. It demands both conditions to hold. Now let's look at a more flexible operator, disjunction. Disjunction is written as P or Q or P cup Q. The statement is true if at least one of them is true. It is false only when both are false. This is called inclusive OR, meaning having both true is perfectly acceptable. Now let's explore two important variations, NAND and NOR. NAND is simply the negation of AND. It is false only when both inputs are true. In every other cases, it is true. NOR is the negation of OR. It is true only when both inputs are false. These operators are extremely important in digital electronics because entire circuits can be built using just NAND and NOR gates. The next operator is exclusive OR. Exclusive OR written as P XOR Q means one or the other, but not both. It is true when exactly one of the inputs is true. If both are true or both are false, the result is false. So XOR checks whether the inputs are different. The next one is conditional or implications. The condition statement is written as P implies Q. It means if P, then Q. The statement is false in only one situation, when P is true and Q is false. That's called the broken promise case. In all other cases, the statement is true. Even when P is false, the implication is considered true because The condition was never activated. The next, converse and inverse. Now let look at two related forms. The converse switches the statement Q implies P. The inverse negates both parts. Negation P implies negation Q. These may look similar to the original implication, but they are not logically equivalent. Confusing them often leads to logical mistakes. The next one is contrapositive. The contrapositive is written as negation Q implies negation P. Here we reverse the statement and negate both parts. Unlike the converse and inverse, the contrapositive is logically equivalent to the original implication. They share exactly the same truth value. This idea is very powerful in mathematical proofs. The next one is biconditional. The biconditional is written as P if and only if Q. It is true when both statements have the same truth value, either both true or both false. It is equivalent to saying P implies Q and Q implies P. So both directions must hold. And then tautology and contradiction. A tautology is a statement that is always true, no matter the truth values. For example, P or not P. The contradiction is always false, like P and not P. The statements do not depend on variables. They represent universal truth or universal falsehood. All these operators together form a complete logical system. Truth tables are not just abstract mathematics. They are the foundation of digital circuits, programming logic, and structured reasoning. If you master tables, you master logical thinking. And that is the true architecture of truth. Thank you.